So good morning students. Today I want to explain a new chapter that already we have discussed yesterday about a topic that is sets. We'll go with the introduction of sets. As we got the previous definition in your class, one boy has mentioned that a well-defined collection of objects is known as a set. I immediately asked what is meant by well-defined collection. What is the difference between a collection and a well-defined collection? What is the how we can differentiate both collection of objects and well-defined collection of objects? We'll go with some examples and we will decide whether which is well-defined and which is not well-defined. So if you go with the first question, interesting story books, is it well-defined collection or not? We'll see. Is it well-defined or not? So, and then favorite heroes. Okay. And three strongest person in the world. And very good boy in your class. And then some even numbers. So, even numbers less than 10. Primes which are even. Stars in the sky. So, if you observe these examples, we can see here a little difference over there. Interesting story books, this will not be common for any two persons even. It may be common for one or two, but if I ask the interesting story books in your class, I will not get the same answer for all. All students will not say the same book. They will say different books. So this is one. This is not well defined. And favorite heroes, definitely you will mention different names of individual. So each student will not give the same hero name for all. It may be common for 5 or 10 students, but all the names will not be the same. So this is not also well defined. And the three strongest person in the world, no one, even myself, anybody will not say that I am the weakest one in the world. Who will admit that I am the weakest person? No person will admit that he is the weakest. So the strongest person in the world is definitely we cannot write, because if they ask them, I will write my name and other name. I will not write. I will not miss my name. So that names are not common for all. So very good boy in your class. Maybe is it empty? No, I think you are all good. So very good boy in your class. Even if I asked who is the very good boy in your class, even that is also not, that set will not be the same. That elements, that means that objects will not be the same. Why? Because nowadays we are saying that like the statuses and movies and from statuses, everybody saying that I'm bad, I'm not good. Okay, even in that case also, if you don't write your name, you are so impartial, you will not write your name. Even that also, that elements, that objects also not the same, because you will write your best friends names as a good boy and remaining writes their best friends if they are not partial, because they will not write my name. But when you give this answer, very good teacher in your school, definitely I will say my name, definitely. So I am partial, definitely I will write. So that's why it is not common. Even some even numbers, if you go with some even numbers, so many will write, I will write 2 4 6, somebody will write 10 12 14, other will write 20 24 26. So this is also not common. While coming to these examples, even numbers less than 10, if we ask anyone, they will say that the even numbers less than 10 is 2 4 6 8. They will definitely, they will mention 2 4 6 8. Even naturals. So primes which are even is nothing but only one number, that is 2. So about the stars in the sky, why I have given this example is, so many students will feel that if there are more number of the objects, this may not be a set. No, even if there are more number of in a objects, it may be set, but set is a should be well defined collection. That means what are in your collection? In my collection, stars are in my collection. So if I say earth, earth will not be in this collection. If I say sun, a sun will be in this collection. If you say moon, moon will not be there in this collection. That's why I have given this example is, this reveals what is meant by well defined. So what is meant by well defined collection of objects? We are in a position to say which objects are related to that collection, which objects doesn't related to that collection. I am repeating, the well defined, see I have defined very clearly so that I get the name well adjective. So why should I go with well defined collection? So well defined collection means that collection is not a collection which is taken at random. I have taken a collection and I have defined it very clearly, like how what are the objects will be there in that collection I can say, and what are the objects doesn't belong to that collection also I can mention. So in a collection, if I am able to distinguish the objects in it and which are not in it, then it is said to be a well defined collection. If you observe the examples whatever we have taken there, interesting storybooks, it's not well defined, since I cannot say that which storybooks will be there in the collection, which storybooks will not be there in that collection. Favorite heroes also is not a well defined collection, since I cannot say which heroes are in that collection and which heroes doesn't. The three strongest person in the world, the same way I am repeating the thing, I cannot say which persons doesn't in that collection, which persons are in that collection. Very good boy in your class, I can't say which object belong to that collection which doesn't. Some even numbers with the same case. But if I go with the last three, even numbers less than 10, definitely I can say that even naturals I am mentioning, even naturals numbers less than 10, definitely I can say that 2, 4, 6, 8 belongs to that collection, and remaining even numbers doesn't belong to that collection. Primes which are even, only 2 belong to that collection, 2 belongs to that collection, and remaining primes doesn't belong to that collection. Stars in the sky, in that sky I have to take only stars to that collection, non-stars, the star which are not stars will not be in that collection. So if you define, if you are in a position to say whether the objects are there in that collection and which are not in that collection, then it is said to be well defined collection. Such collections are said to be sets. So we'll move on to the next. So we'll have one more idea what is the process this. We are all familiar with ordinary process of long division. We know that one integer by another integer, and that process can be carried out until we get the remainder. So how we'll get the remainder? Already we have done in real numbers. For example, if I take with 27 with something like 2, so I'll get 2 ones are 2, and I will go like up to 7. So I will down 7, and will I stop here? No, I won't stop here. Why? Because I will carry this division until I get a remainder. So how you can say that it is a remainder? See, 7 is also a remainder, no? No. So still I can divide 7 into 2 parts. So that's why I will write 2 3s are 6 and the remainder is 1. I will stop this one as remainder. How you can arrive into such conclusion as when you got a number which is less than the divisor, that you can say the remainder. This is the process generally what we will use in division. Okay, so this is a integer with another integer until we get the remainder. Also, we might have had that idea that remainder is always less than the divisor. Then only we can stop this. So this process, see this in I have explained this thing, this total division thing in these many lines. Now I am asking, is it any simplified version to give a mathematical statement? This division process, can you give? any like a mathematical statement in one statement. Yes, we have that Euclid division lemma in our real numbers. So what is that? For given integers a and b, there exists a unique pair of integers q and r such that a is equals to bq plus r and 0 less than or equal to r less than b. Observe here, this mathematical sentence arrived by basing on this total process. The thinking of the process is nothing but, see, I have taken some collection of integers, some collection of integers which satisfies our process. That equation gives the real numbers. That comes under Euclid division lemma. Euclid has given this statement by thinking all this process. So for given integers a and b, there exists unique pair of integers q and r such that a equal to bq plus r, where 0 less than or equal to r less than b. See, we are doing the division. This is nothing but division. In first chapter I have explained that you don't worry about all these equations. It is nothing but division. We have make it into a mathematical statement. So we told that the remainder is always less than the divisor. That we have shown the symbolical way. So how you can arrive this? You have taken some collection of integers and now you have well defined. These numbers become a set which follows Euclid division lemma. So the same you can apply for various mathematical statements which finally comes with some conclusions. So all these problems, we know how to solve a problem, how to divide, how to get the quotient, how to get the remainder. Even after solving a problem, it is necessary that we have to generalize that mathematical statements with logic. That's the logic we have given, that a is always equal to bq plus r, where 0 less than or equal to r less than b. So this is where we have to take all whatever we have done, the statements whatever we have learned previously, that should be combined, and we have to earlier generalized statements to form new statements. So already first we will take one generalized statement and that should be used for another, as we have done. Remainder is always less than the divisor. That statement we have used here, 0 less than or equal to r less than b. Division here, a equal to bq plus r. So various theorems, all maximum Euclid theorems, you know that introduction of geometry in your previous. So all the theorems of great mathematicians because of this process of thinking. So here we can say that mathematics has that beauty here. After completion of that statement, definitely some questions arises in our thinking, like, is Euclid division lemma applicable to all real numbers, or is it applicable to only integers? In both cases, how we can arrive? We have arrived with collection of some things. That means collection of real numbers, collection of integers. We'll take collection of irrationals and we will check the division lemma. If the division lemma is applicable to that, so those collection of things becomes a set which satisfies the rule. So the things what we will do is, we will find a common property. The numbers which satisfies all these conditions will come into our set. The students which who are studying 10th class is a common property. What is the common property in your class now? You are all studying 10th class. That is common. It is irrespective of anything. And if you take the school or section C1, what is the common property of C1? Maybe they have the first room. That is the common. After the steps, it will maybe your room is the first. That is common property for all. So like that, you have to identify the common property. That common property decides our set. So what is it? How you can write a set is, we will collect a collection of things which have the common property for all. And we will see that common property, it can be anywhere. By using our logic, that common property also need not be the same always. For example, I told you that you are all belong to the 10th class and uniform is a common property in your class. So that uniform indicates you are belong to sentence. So somebody will have their common property is different. I told that uniform, that means your shirt is common for all, or someone can say the belt is common or shoes is common. That will be different. By finally, I have to say that you are belong to sentence school, if it is a school name. So like that, that's the common property. We will apply the logic to decide the common property. That common property gives us set. I will give you a task here. Identify and write the common property of the following collections. So first one is I have given 2, 4, 6, 8 and so on. You can write the common property anything. I don't mind. Third one is 2, 3, 5, 7, 11 and so on. And third one is 1, 4, 9, 16 and so on. Just you write it and give me that. So you know that already. So what is the common property of 2, 4, 6, 8 and so on? This is even numbers, even naturals. How to say even naturals? Because if I don't mention naturals, it may become integers. If I go with integers, I have to keep 0 also. So what is the common property in 2, 3, 5, 7, 11? Primes. You don't mention prime naturals because primes itself is natural numbers. And 1, 4, 9, 16, once you observe, squares of natural numbers. 1 square, 2 square, 3 square, 4 square. So these are what is the common property that should be common for all. It should not be changed like that. For example, if you take this one, this is common properties. If I say the difference is 1 and difference is 2, difference is 2, difference is 4, see, it is changing. It's not common. Here, their difference is consecutive numbers, difference is 2. That's also common property. You can say that property or otherwise even naturals. You can use any common property like that. As many as common properties you can define for these questions. That's your wish. We can write that. So similarly, January, February, March, April. I need the answer from you this January, February, March, April. So what is the common property in that? So and then thumb, index finger, middle finger and ring finger. What is the common property in this? So I have to find this. These are the common, this is the task I am giving to you. You just finish. So then one more question. Observe the following collections and prepare as many as generalized statements you can describing their more properties. I want that the same thing should not be given. 2, 4, 6, 8, the common property is not always even naturals. 1, 4, 9, 16 is may not be the squares of a, not only the squares of a natural number. Can't you write any generalized statements? If you want to write more generalized statements, yes, you can. Whatever the generalized statements you can do, that you can finish this. Now I am going to the definition of a set. A set is nothing but a collection of things that have something in common or follow a rule. So here what we can say is a set is a collection of things that have something in common or follow a rule. Without any common property, without any rule followed by all the objects in that, we cannot take that collection as a set. If you want to take that collection as a set, they should have a common property. Otherwise, they have to follow a specific rule. If they don't follow a specific rule, or if you don't follow the collection of things, then don't follow a common property, then you cannot take it as a set. If you want to take it as a set, definitely they should follow a rule or they should have a common property. So now the most important lines are, the things in the sets are called elements. So whatever you write in the set, for example in set I have written the names of the students of classes. So that I can write with some names, Ramu, Razu, Ramesh. If I write the names like that, Sita, if I write the names like that, see, these names will be called as elements. You should not say the names. You have to say these are the elements of that set. And the set notation is always uses as braces. Flower braces should be written. We should not write like some brackets like this. The set braces must be written, and the all elements should be written by separating the commas. Denotation is more important, so all elements should be denoted by separating the commas. So how you can decide the set is that common property. Whatever the common property is there in the for all the elements, that common property will be deciding factor for definition of a set. So I am repeating. So a set is nothing but a collection of things that have a something in common or follow a rule. All the sets are denoted by capital letters. Remember, sets will be denoted with capital. Already you know the sets. Natural numbers, n is a set of, without learning the definition of a set already, we have already given that set is nothing but a collection of objects there. So set of natural numbers 1, 2, 1 comma, 2 comma, 3 and so on. These are all elements and we can separate them commas. We will use the flower braces. So all sets are denoted by capital letters and elements are denoted by smaller letters. So we have already known about this. So common property is must. We have to identify the common, because while describing a set, it is very important about learning the common property. So then if you go with some examples, if you want to write a set of first 5 prime numbers, how we can write? We'll write 2 comma, 3 comma, 5 comma, 7 comma, 11. And if they ask a set of incisors in your teeth, then you have to write central incisor, lateral incisor. So see that what I have written first 5 prime numbers. So prime numbers is the common property and I have to go with first 5. So I have to write only the first 5 separated by the commas 2 comma, 3 comma, 5 comma, 7 comma, 11. And set of incisors, the common property is incisor. I cannot write premolar and molar in this set because the common property is incisors. So that's why I should go with premolar and molar. So I will give you another task. Write the following sets. How you can write these sets, we'll see. Set of the first 5 positive integers. Remember, you have to write the set with the set brackets and element should be separated by commas. So set of first 5 positive integers and the set of multiples of 5 which are more than 100 and less than 125. So, and set of first 5 cubic numbers. Remember here, whatever we are giving, that is nothing but a common property which I am describing for that collection. That common, basing on that common property, you have to select the objects which satisfies that common property or which follows the rule. Those will be the things. So set of digits in the Ramanujan number. Already you are all know that what is a Ramanujan number. So in that set of Ramanujan number, you have